Okay, we'll discuss Unit 5. Same as Unit 2, that 35 marks will come. Most of the times 10 marks theory plus 25 marks problems. So here one design of column is there, and three types of problem. First one, calculate the design compressive load. Second, design of column, almost same problems, both little different in the initial stages. And third one is the design of slab base. The slab base will come for 15 marks. So most like a Unit 2, this module also somewhat important module or unit. So we'll start with one. Calculate the design compressive load for a column ISHB 350 at 710 Newton per meter, 3.5 meter high. The column is restrained both ends and steel of grade Fe410. These are the given data. I will not discuss. L is 3.5, 3500 mm. For ISHB 350 710.2 Newton per meter. We need properties. So we'll go with the page number 12 here written. That is not in the 12, that is in the 14. Page number 14, there will be a ISHB 350 will be there. I'll open the page number 14 where ISHB 400, ISHB 300, right? ISHB 300 or 350. ISHB 350 is here. So ISHB 350 at 710.2 Newton per meter, right? This is the correct 710 Newton per meter. And the values, H values, PF values, TF values, TW values, R1 values, whatever the values required, everything you note down from the steel table. This is in the page number 14 where this is the I section, right? This clearly indicates the I section. So this is page number 14. Okay, anyhow. We got the area value, that is in mm square should be there, means in code steel table it is mentioned as 92.21 centimeter square. It means 9221 mm square. H is 350, BF is 250, TW, TF values so I have to note down from that table. Then we have to go to page number 138 of the code book, right? To find out RY and RZ values we need code book also. So here for ISHB 710.2 Newton per meter, right? 710.2 Newton per meter. RY value is 14.65 mm, 14.65 centimeter, in the sense 146.5 mm. Same way RY, first one is RZ, second one is RY, that is 5.22 centimeter or 52.2 mm. I'll show the code book page number 138. This is page number 138 where ISHB 350 is here. ISHB 350 both are there. One is at 67.4, one is 72.4. This one is given in the question, so 72.4, where you have to go with the RY and RZ values here, right? 14.65 is the RZ value and 55.22 centimeter is the RZ value. We need in mm, so we have to multiply by 10. That was I did 146.5 and 52.2. So assume buckling class C. We have to assume buckling class C. Why I will tell later. Otherwise we have to find out which class it is. Better going with the assume buckling class C. Then we have to find out lambda y. This formula lambda y is equal to KL by RY. This formula is not there in the code book. We have to remember where K is 0.65. Always K is 0.65. Remember 0.65 is the K value always. Then L value is given 3500 and RY is 52.2. So LW we will get the lambda for 43.58. Then page number 42 of the code book. Page number 42 of the code book means for class C, right? We written that assuming buckling class C. So page number 42, there will be a table. So find out the lambda and FCD values. FCD is nothing but the bearing stress or design compressive stress. This value we have to find out from the page number 42. There will be a table of KL by R values and the FY values and FCD values. Yes, I'll show the table now here, right? This is the table where mentioned buckling class C, and this is page number 42, and this row is of KL by R values, means lambda values, or this is yield stress FY. right? Fy is 250, our Fy is 250, so this column only needed for us. And the values here, you see, we got the 43.58. so in the table we have lambda values 40 and 50, so both you have to take it, 40 and 50. 40 and corresponding to 250 it is 198, for 50 corresponding to 250 is 183, so that's two are taken here, 198 and 183. Got it? This is 120 and 193 for 40 and 50. We need for 43.58. So this formula used for to calculate the values. First you have to add 198 maximum value minus 198 minus 183, that is bigger value minus smaller value, divided by on the left side also 50 minus 40, multiplied by the value of 43.58 minus the lower value, or else you can calculate directly by using calc with the stat option. I think most of the students are aware of stat option. If you are not aware, you can contact me, I'll help you. So how to find out this? If it is this formula is okay for you, then you can go with that. Otherwise you can directly calculate this option by using calculator. So finally FCD we got it 192.63. so finally design compressor strength, how to find out PD is equal to AE FCD, where A value is we taken from the steel table, that is 9221 mm square. This value, this area value multiplied by the FCD value 192. So this problem doesn't carry much steps, but it will come for 10 marks at least. So this problem is easy to score for 10 marks. The second problem, you see, design, right? First problem, they given find out the design compressive load by giving the column. Here they didn't give a column, they told us to design a column, right? Design a 4-meter high column of steel Fe410, working load of the given load of 600 kilonewton, right? So factored load, first you have to find out, that is 1.5 into 600, that is 900 kilonewton. Then assuming FCD, here FCD we are not finding, we are assuming, that is 0.6 Fy, 0.6 into 250, that is 150 Newton per mm square. So whatever FCD we got, we have to find out the area, that is nothing but load by FCD. FCD we assumed load is given, factored load, that is 900 divided by FCD is 150, that is a total area we got is 6000 mm square. So 6000 mm square area we needed. For that, what you have to do it, you have to go to steel table and you have to find out where we are getting 6000 mm square values, and that has to be taken for your column of 400. Here I take an ISSB 250 because it having area of 6496 mm square, more than 6000. It is taken from the steel table. I'll show from the steel table. Yes, here you see page number 14. This is I section. It is here, high section is here in the 12 also, 14 also high section. So here we need 6496, right? More than 6000. So here you can see more than 6000 anywhere. Here it is 6496. We taken this one ISHB 258, 51.0 kg per meter. This is kg per meter, this is Newton per meter. So 51 point, this has to be written ISHB 250, area is 6496, and the rest values H, BF, TF, TW, all the values has to be noted down. So H is 250, BF 250, 8.7. Same way in the previous pages, previous problem also we did that. Page number 138 of the code book, where ISHB is 250, we want RY and RZ value. So shown in the previous problem how to calculate, see from the code book on the page number 138. So H by BF is you have to find out here. H by BF is 1 less than 1.2. Same way TF is less than 100. This stuff you can write or you can skip also, right? You can directly write buckling class C. Same way in the last problem. So where we have to find out lambda value, KL by RY, that is K value is 0.65, always constant. I told in the previous problem also. Then 4000, the 4 meter column height is given. Then Ry value is 54.9. That has to be substituted and you will get the lambda value. After getting lambda value, what is the process? Page number 42. I'll not show you again. You know it. Codebook FY 250 for the KL 40, 50, 198 and 150, 47.35. How much? How to calculate by using this method or by using calci. So we got FCD as 186.975. Then you have to go for the compressive load. PD is equal to AFCD. A is 6496. That is whatever the angle we selected, the area of the angle. Then multiplied by FCD, that is 186.975. PD is equal to, you'll get in terms of Newton, it should be in terms of kilonewton, and the value we're getting should be more than whatever the factored load given or the load we calculated factored load. Initially they will not give, sometimes they'll give factored load. If they give factored load here, if they give factored load directly, they give a working load. If they give a working load, you have to multiply 1.5. If they give directly factored load, don't need to multiply 1.5. So whatever the answer finally you are getting should be more than factored load, right? Hence it is safe. Otherwise you have to select a different section more than ISHB 250. Now we'll go with the design of slab base of the given design a slab base ISHB 450, right? This is the column ISHB 450. For that we have to make a slab, design slab means a foundation for the 450 slab base. 450 carrying axial load of 1000 kilonewton, Fe410 steel, M25 grade concrete, right? Design welded connection. If they say design welded connection, then you have to go with the welded connection, otherwise no need. Whatever the data given, M25 grade, that is FCK, FU is 410, then P is 1000, factored load is 1500, SHB 450. From the steel table take H value, BF value, TF value, TW values. These values required. Then have to find out required area of the base plate, that is load divided by bearing strength of concrete. Load is nothing but 1500 kilonewton, that is the load. Then bearing strength is 0.45 FCK. Remember 0.45 FCK. 0.45 is constant, FCK is 25 given. So 0.45 into 25, you will get this much of area, 1,33,333. So what you have to do it? You have to draw a diagram of ISHB 450. ISHB 450 is H is 450 and BF is 250 here. So H is 450 and BF is 250, and then you have to make a column outside. What you have to do it in this one, I have to first initially have to give 50 spacing. What is the spacing here, right? This is the spacing here, and same way in this direction also. This spacing is called as projections or A and B values, A and B values, right? This you have to take 50 mm on both sides, then 250 plus on this side 50, this side 50, you'll get 350. Here same way, 450 plus 50 plus 50, that is 550. So totally 350 into 550, you have to find the area. You'll getting 1,92,000, more than 1,33,000. So if it is more than 1,33,000, then it is okay. Otherwise you have to increase the spacing. Whatever 50 is there now, you increase to 75 both side. Then you need to check again if condition is satisfies, okay. Otherwise again you have to increase to 100. That's process you have to do it, unless you have to get the area required more than required. You're getting 1,92,000 more than the 1,33,000. So in A and B I said, that is spacing or projection, that is 50 mm we needed. Then you have to find out bearing pressure of concrete, that is W is equal to factored load by area of the plate. Factored load we got it, area of the plate is 550 into 350. Then you are getting the W values. Then page number 47 of the codebook, we have to go to the page number 47 of the codebook. We have to find out the thickness of the slab base, how much thickness we have to give it. I'll show in the page number 47. Here page number 47, this formula we have to use it, right? Anyhow, just I shown, this is page number 47. Anyhow, the TS values you have to find out. 2.5 W into A square minus 0.3 B square into gamma m naught. Here one bracket is there, right here on bracket, then gamma m naught divided by fi should be more than tf value. So we have to find 2.5. W is whatever we calculated. A is 50, B is 50, then gamma m naught is 1.1, fi is 250. We are getting 12.24, which is less than 13.7. What is 13.7? The tf values, right? Here what is the tf value? Tf is 13.7. So here tf should be right, value should be more than tf, right? Ts value should be more than tf, but here 13.7 is the tf value and we got 12.24, less than tf. So this condition is not satisfied here. That is why hence ts is less than tf. We have to go for as per IS standard. TS should be more. That's why you have to give more than 13.7. We are providing 14 mm. So base plate is now 515 to 315 to 14 mm thickness. Now base plate design is over. Now we have to go for the welded connections. So size of the weld you have to assume initially 10 mm. That is nothing but S is equal to 10 mm. Then you have to find out total available length. The formula is 2 into B plus H minus TF minus TW. You will with all the substitute values you have to substitute, then you are getting the total length available for the weld, that is 1350. Then you have to go for the Pdw formula, which you are by hearted in the second model itself. Lw into tt into fu by root 3 gamma mw. So where tt value you have to find out, that is 0.7 into s, 0.7 into this and all you studied in the second module. 0.7 into 10, that is 70 mm. Then you have to go with the Pdw. Lw is unknown, 7 is a is 7, 70 is the tt value, this is not 7, 70. Then 410 you root 3 mw, gamma mw is 1.25. Then here Pdw value, right? Pdw value whatever we are getting here, that is 1325.59 lw, which after simplification you'll get in terms of lw. Pdw, whatever the Pdw value is there now, that has to substitute initially what is the load given in the question, that is 1500 kilonewton. That value has to be substituted, 1500 to 10 raised to 3 here is equal to this much. So whatever the lw value we are getting, 1131.57, should be less than this value, total available length. What we calculated here, total available length, should be more than whatever lw is getting. Lw is less than that value, then it is okay. If it is more than, if it is 1400, more than 1350, lw is more means, then you have to increase the s value here. Then again you have to increase the s value as 12 mm. Then do again in the same process, then you have to check it again whether we are getting or less or not. This process you have to do it. For this you will get 15 marks for slab design. So I think module 5 is easiest to score for you, so do well. Now it is in your hand. Over one module is left, that is unit 6. We'll study in the next video.